Hello everyone. In this video, we're going to be solving an interesting equation. I call it interesting because notation-wise, this kind of looks like an abuse of notation. Is it? I don't know. But we need to talk briefly about dx and dy. As you know, those are infinitesimals, right? They kind of represent change, but at a very, very small scale. Like infinitesimal basically means like infinitely small. But I'm not going to get into the nitty-gritty. There's a lot of theory behind this. But this is the equation. So we kind of have like a really weird equation. You know how sometimes people say, hey, can you integrate x to the power dx? Can you? Let's find out. So we have e to the power dy equals x to the power dx. And we're supposed to solve for y. So for those folks who complain about me not telling you what to solve for, we're going to be solving for y here. Yay, let's find y. Okay. Now, I'll be presenting two methods, but the second one is not an actual method, just for fun. So I'm telling you ahead of time, do not take the second method seriously. And don't use it on an exam, because you'll get in serious trouble. All right, anyways, let's go ahead and start with the first method. So since this equation kind of looks real weird and non-standard, let's put it into a nicer form. And we can do the following. Why don't we just get, okay, this looks like something we are familiar with, dy over dx. Doesn't that mean the derivative of y with respect to x or y prime? Yeah. How can I get dy over dx from here? That should be your motivation. So let's go ahead and raise both sides to the power 1 over dx. What does 1 over dx mean? I don't know, but it works. Let's go ahead and do it. Sometimes you don't care what it means, we just do it. So when we do it, dy multiplied by 1 over dx is obviously going to be dy over dx. And the right hand side, we're going to get something super duper nice because dx is going to cancel out. Yay! We got something a little bit more meaningful, but still weird because dy over dx is in the exponent. And you don't want that. Why? Because it's better if it's not, all right? So let's go ahead and ln both sides. And when we ln both sides, something nice is going to happen. We're going to get rid of the exponent. Yay. Okay. dy over dx, we can kind of move it here. And ln e is equal to 1, right? I think so. So from here, we get dy over dx is equal to ln x. So here's what I want you to think about. Is there a function whose derivative is ln x? Interesting. So let's go ahead and find out. So I would multiply both sides by dx to get my d, because in integration, you don't want to have dy over dx, but you want to have d something. So dy can be written as ln x dx. Now at this point, I would like to integrate both sides. Let's go ahead and integrate both sides, and let's see what we get from here. Integral of dy is going to be y, and now the integral of ln. Now, I know a lot of people, especially those of you who've taken calculus recently or interested in calculus, I'm pretty sure you memorize this, right? The integral of ln x is equal to x ln x minus x. And don't forget the constant, otherwise your professor will be mad. So yes, this is the function whose derivative is ln x. How can we check that? So, well, you can just differentiate it. What happens if you differentiate x ln x? From product property, you get the derivative of x times ln x plus the derivative of ln x times x. And this gives you ln x plus 1. So I get an additional 1. I don't want that. So how about subtracting an x from here? That way, I'll be getting the derivative of x ln x, which is ln x plus 1. And then the derivative of x is 1. They're going to cancel out, and we're going to be happy. Everybody is going to be happy, hopefully. All right. So that is the integral. Of course, we have a constant here. And something, again, a lot of times people memorize this because it comes up a lot. But if you didn't know this by heart, you could also use, what is it called? Integration by parts, right? You could definitely do the following, the u dv thing. You can call this u, you can call that dv, and then from here, you can do uv minus v du, and so on and so forth. I'll spare the details for the reader as an exercise. Okay, so let's go ahead and talk about the second method. But one more time, this is not an actual method, so you've been warned. This is just for fun, okay? Just for fun. Don't take it seriously. All right, great. So here's what I'm going to do. I'll pick up where we had this e to the power something equals x. So here I'm going to do something fun, but definitely not true in general. I'm going to cross out the d's, like treat this as d times y and d times x, and then we end up with something simpler, e to power y over x equals x, and then I'll be ln'ing both sides. Again, this is for fun. Don't take it seriously. I keep saying it because I'm afraid some people are going to use this strategy on the test and they're going to say, hey, I watched a YouTube video that talks about this technique. What technique? Anyway, so from here we get y over x equals ln x. And if you multiply both sides by x, you know, if everything goes well, we get the following. But where's the missing x? Well, notice that we have an x on the right-hand side. That's an extra, so why not subtract it from both sides or from the right-hand side? And of course, don't forget the constant because this is a differential equation. And this brings us to the end of this video. Thank you for watching, just for laughs. I'll see you tomorrow with another video. Don't forget to comment, like, and subscribe. Until tomorrow, take care, be safe, and bye-bye.